Okay, sorry for the delay. You're going to have to watch, a lot of the examples from today's lesson online yourself. There we are. Okay, questions on the homework? Yes, ma'am. Yes.
On question 24, when they ask you to sign the cosine graph,
Yep.
what was the first or left of those?
So is that section 1.4? 1.2. Okay. Let's talk about that one. That's not something that you need to necessarily remember. It's just like graphing any function. So sine of x when x is less than 0, 1 minus cosine x between 0 and pi. Cosine of x is greater than pi. The key to that one, and I'm showing you it down here, and I will do it again, is what's your inputs? Well, you don't have to do 0, 1, 2, 3, 4 on your x and y axis. You can do 0, pi over 2, pi, 3 pi over 2, 2 pi, or any kind of variations of that. So there's 0, I could put pi over 2 right here, pi, 3 pi over 2, etc. And then I could go the other way as well. And if you know your unit circle, you can graph sine of x. What's the sine of 0? Sine of 0 is 0. So for the sine of x, which I'll do in black, we will kind of be ending here at 0, 0. We will not be including that point, but all the points up into that point will be included to the left of 0 for sine. If I talk about negative pi over 2, the sine of negative pi over 2 is negative 1. So negative pi over 2, negative 1. And here is my first piece. And it'll continue to go up and down that way. And you can kind of remember that, but if you don't, you just need to know that it's going to be continuous, right, to the left. Second piece in red, 1 minus cosine of x between 0 and pi, including 0 and pi. So if I plug in 0, the cosine of 0 is 1. 1 minus 1 is 0. So the black piece will meet up with this middle red piece. Pi over 2, the cosine of pi over 2 is 0. So I'd have the point pi over 2, 1. Then pi, cosine of pi is negative 1. 1 minus negative 1 is 2. So I have this point pi 2. I'll be able to connect these in like a cosine graph, sine graph. You just know that it goes up and down. That's the one thing I guess I would expect you to know, is that it curves up and down. And then cosine of pi, you should be able to do, I'll do this one in blue. Cosine of pi is negative 1, so I'd be picking up this last piece with an open circle since we're not including pi in cosine. But cosine of 3 pi over 2 is 0, so we'd go like this. And we'd go up to 1 and keep going. So the question is, where do limits exist? Well, if we just look at the individual pieces on its domains, they would exist everywhere. The big question with these piecewise functions is, do the pieces meet up with each other? Does sine meet up with 1 minus cosine at 0? Does 1 minus cosine meet up with cosine at pi? And you can see by looking at the graph that at 0, the limit does exist and it equals 0. But at pi, the limit does not exist. The limit as x approaches pi from the left would be 2. And the limit as x approaches pi from the right would be negative 1. So the limit does not exist at pi. Therefore, we would say the limits exist for all x's such that x does not equal pi. Or I think the question asks for c's, so you can say all c's such that c does not equal pi. Okay? Does that make sense? Yeah. Other questions? Yes, ma'am.
Number 7 in section 1.4.
Number 7, 1.4.
The answer is 1/4, and I get how they got it, but I don't really get why it's, 1/4 instead of 4.
Okay, well, the key for this one is we should probably graph it and see what's going on around 5. So let's do that. So we're talking about number 7. I will graph clear it out. Include it. Quantity x minus 5 divided by quantity of x squared minus 25. Okay, and up until now, you should know how to find limits using a calculator. Obviously, I graphed more than one. Let's get rid of this top one. This is for later. Okay, there is x squared, or x minus 5 over x squared minus 25. Well, I can see if we have a value at 5. I press trace and I click in 5, and y is equal to nothing. So it's undefined there. I can tell by plugging in 5 into x minus 5 over x squared minus 25, I get 0 over 0, which is undefined. Okay, but the question is, what is the limit as x approaches 5 from the right? Well, what can I do? I can kind of see where the cursor is close to, and we're down here. But if I press trace, I can also type in any value I want. So 5 to the right, that'd be like a value of 5.0001. Maybe that will help me figure out what the value is close to right there at 5. Well, I see my function looks like we're approaching a y value of 0.1. It's probably not exactly 0.1. The calculator probably just rounded it here. And I could probably show that if I typed in like 5.001 instead of all of those zeros. See, 0.099999. So you can see from the right, we're approaching 0.1. If I check the same thing from the left and I plugged in 4.999, we'd also be approaching 0.1 as well. So we have a hole on our function right here. And the location of the hole is at the y coordinate of 0.1. Does that make sense? Limits are all about what we're approaching. We don't care what's going on right at the value. I don't care what's going on at 5. I care what's going on to the left and to the right of 5. Just to the left and just to the right. I could literally take my pencil, put it right over this point on a graph, and not care what's going on. We could have an open circle, a closed circle above it. Doesn't matter. It's just that my function values are just going to be approaching the same value, and that value is 0.1. Okay, other questions? Yes, sir. 64. Okay, we have a true-false statement. The question is, if the limit of f of x as x approaches c is 0, then there must be a number k such that f of k is equal to, f of k is less than 0.001. This is a good question. I'm going to use a graph to help us understand this. So we're saying we know that the limit as x approaches c is 0. So I don't know what the graph looks like. All I know is that as we get closer to c, our function to the left and to the right will be approaching 0. I don't know what's going on at c, so I'm not going to put anything at c. Could be an open circle, could be a closed circle. Okay. Question is, the statement is there must exist a number k such that f of k is less than 0.001. Well, k then is going to be an x value since we're talking about f of k. So here is an x value k. The question is, can I drag k somewhere so that the y value I get is less than 0.001? What do we think, Mr. Wolf?
Well, it says that there must exist a number k such that equals that. So it doesn't have to. If the other side is
let's see. The other side of the graph, you are correct. Could go up. But we still know that the other side of the graph from the right is going to be approaching 0 at C, right?
What if the other side of the graph didn't exist?
Then we wouldn't have a limit because we need that left side and the right side to have the limit. Okay? Now, that means if I go really, really close to C, Mr. Wolf, what are my y values going to do? Smaller and smaller, closer and closer to 0. Do you think I could go close enough to C so that my value is going to be less than 0.001 for my y value? Yes, definitely. No matter what my graph looks like, if I know I have a limit at C that's equal to 0, I know that if I just go just to the right of C, C plus 0.000001, my y value is going to be really, really close to 0. Might be positive, it might be negative, but it'll definitely be less than 0.001. Okay? Okay, other questions? Yes, sir. Number 16, 1.4. Okay, we want to figure out the limit as x approaches 2 of that function. And we got a piece when x is less than 2, and we have another piece when x is greater than 2. Well, we know this is continuous everywhere. It's going to have limits everywhere. We know this piece is continuous everywhere. It's going to have limits everywhere. The question is, are they going to meet up at 2? How do I figure that out? I could graph it if I wanted to, or I could just take 2 and plug it in for x and see if this value will meet this at 2. So I plug in 2, I get 4 minus 8, which is negative 2 plus 6 is 4. So I got 4 for the top. Here I got 2 squared, which is 4. I take the opposite of it, negative 4 plus 8. That is 4 minus 2 is 2. What did I say? The top one was 4. The bottom one was 2. They're not meeting up. The limit does not exist.
So if you just plug both of them in to find the y value, if they meet up, they'll have a limit there. And
Yep.
if they don't, they won't.
Yep, that's it. So the question is, do these meet up and form a curve, a continuous curve, or do they have a jump? And it looks like this one's going to have a jump. I'd have a situation where the one of them is going to end up here at 4, and the other one is going to end up or start here at 2, like that. Yes?
Leave the top one equal 2 and not 4.
Did I make a mistake?
And you said 4 minus 8 is
4 minus 8 is negative 4, plus 6 is 2. So this is 2. I made a mistake. So it turns out, take this piece and lower it. They will meet up at 2, which means the left side and the right side are going to meet up equal the same value. So the limit does exist. Yes, ma'am.
So all you did there was plug in the number where their boundaries and just into the equation to find the function value?
Yes, essentially. You could graph if you wanted to, and just kind of have an open circle for the first one, and then start with your closed circle on the second one, and go from there. But it is essentially just plugging in the values where we leave one and pick up the other one, and make sure that they equal each other, because then they'll meet up and they won't jump. Yes?
So are you okay with us writing in that kind of notation for the look one? Like we just put a limit of x over the first 2.
It's not proper. If you write it like this, you would say of f of x equals. Okay? It's just shorthand. If you just put on an answer slot on your quiz today, 2, it's like, what is the limit as x approaches 2 of f of x? You could just write 2. Okay? Anything else? Okay, good. Let's take our quiz. Pass up your homework to the front, and then the people up at the front, pass your homework to the side. Yep, towards.
You have multiple pages, you want to staple them?
If you have multiple pages, you can just kind of fold them over. That way, I know they are, but it's usually not a problem. Yep, you don't have to staple them. I usually keep good track of them. I'll show you the quiz. There's a couple things I want you to take note on. Okay. Gonna pass out the quiz first. First thing, when you're looking at the quiz, notice the top is the answer slots. And when it says your name, don't put your name. Remember, it's your first or your last 4 digits of your ID number. So first thing is, instead of name, change that to last 4 of ID. When you're done, make sure you put it in the proper slot in the cabinets. So this graph down here, this is the graph for problems 1, 2, 3, and 4. So here's the problem. You use this graph. Really quick, this is an open circle right there, and it's located at 1, -1. You might think that it looks a little bit off, but we can go ahead and just assume it's at -1. Okay. Then on the next page, this should be 3 with an exponent of a minus sign. Okay, I believe it's 3 and the minus sign is next to it on our copies. I put in the wrong copy. Everything else should be good. This is the problem. This is the function you're going to use for 5 and 6 right here. You're just going to put your answer and complete the numerical table on the front page. Yes, sir.
On the back, you say it was 3 with the minus sign to the right of it.
Yes, to the right of it as an exponent.
Also, for just writing in front of this, is the NE okay?
The NE is fine for does not exist.
Do you have any policy for showing our work calculator, please?
No, no policy. You're allowed to use your calculator on this entire quiz. This is one of the few calculator allowed quizzes you will take all year. Yes. Could you guys finish the quiz, then go? Possibly, if I email.
We're writing with the tablet, and I would,
Okay.
if we, do you want me to start it?
No.
No? Okay. I will watch something.
Yeah.
And, like,
Yeah.
I'm not going.
You're not going. Okay.
Is -100 if I say that, I would be like -0.99.
No, I'm saying that the open circle is right at the value. Okay, right at -1. Okay.